Now I'd like to verify the following identity. We have the secant of 2 theta is equal to the secant squared of theta over 2 minus the secant squared of theta. So first decision that we make is decide which side we'd like to start with. I'd like to start with the right-hand side. It's just got a couple more things going on with it. The fact that there's a fraction already there, and I know what to do with those secants as well. In red, I'll include a justification of each step. So on the right-hand side, I'm going to start with the secant squared of theta over 2 minus the secant squared of theta. First manipulation I'd like to do is going to employ the basic strategy of get everything in terms of the sine and the cosine. So I'm going to employ a couple of reciprocal identities. Secant is the same as 1 over the cosine, so secant squared will be the same as 1 over the cosine squared of theta. Oops, we're going to do the same thing for this term in the denominator as well. I'm sorry, a gorgeous lady just walked into my basement, and then she peed in her litter box, and now she's looking to go back upstairs. Good times. Very good. That was use of a quotient identity. Now we have a bunch of fractions inside of our fraction. I would like to get rid of those fractions inside of the fraction by multiplying top and bottom of the big fraction by the cosine squared of theta, which would be the lowest common denominator of all of the little fractions. Now in the numerator, very little is going to happen. Cosine squared of theta over cosine squared of theta, that'll reduce to 1. In the denominator, this will distribute to the two terms that are in the denominator. We'll get 2 times the cosine squared of theta minus, and for the second term, those will cancel each other out. And that was, of course, a step of algebra. You may or may not recognize this form of this identity, but this is one of your double angle identities. It is one of the 3 forms of the cosine of a double angle. So we'll say double angle identity. But now we have the reciprocal of the cosine. Reciprocal of the cosine would be the secant. Angle stays the same, so it'll be the secant of 2 theta. That, of course, would be a reciprocal identity. And I just realized that I said this up here when I was distracted by that beautiful woman in my basement. That should be reciprocal up here as well. Fantastic. Now, that completes the proof. Therefore, give it one of those, and we'll call it good.